Okay, 4.4. Laws of logarithm.
We don't have to join on Zoom during the test, right? We just take it.
So laws of logarithm. So first of all, you have to know let A, B, C are real numbers with A is greater than 0 and B is greater than 0. So the first law first, number one, logarithm of A times B to the base A is equal log of A plus log of B to the same base A, B. So you have to know if I have logarithm of A times B for the base A is the same as log of A to the space plus log of B to the same base. Number two, log of A over B to the base A is equal log of A plus log of B to the same base A. So here the same base, here minus. Third one, log of A, same A to the C, equal C the power goes down, log of A, same base A. Okay, this is the three laws. Logarithm of A to the AB equal log A to A and plus log B to the same base. Same things for dividing. If A divide B, log A to the same base minus log B to the same base. This is the third three property. Some warning here. Some warnings. You have to know that the logarithm for A plus B to the base A is not the same as log of A plus log of B. The same base. This is not true for addition. For multiplication, this is true. Number two, You have to know the log A, same base A, over log B to same A base is not equal log of A over B. This is not the same like this one. For addition is not the same. Okay? Question. Any question? So now example. Evaluate by using the law of logarithm. Log 2 to the base 4 plus log 32 to the base 4. What is that equal? Second one, log 9 over 27 to the base 3. And third one, 1 over 3 log 125 to the base 5. What is the first one equal? By using the properties of laws. So by using here log of A times B to the base A is equal log of A to the base A plus logarithm B to the base E. So right now in the example we have this side. We're going to go over this side. We have log of 2 to the base 4 plus log of 32 to the base 4. So the base are equal. This is the important things. And we have sum. So by using the first properties, this equal what? Log of what? Log of 4. We multiply this by this. 2 times 32. Go back again. Look, logarithm of A to the base A plus logarithm of B to the base A. This is equal logarithm of A. I mean like logarithm of these things times these things to the same base. 4 is 4, 2 times 32. What is that equal? What is here inside? 2 times 32 is?
64.
64. And what is the logarithm of 64 to the base 4? From before, like I have to ask myself, 4 to which power they give me 64? 4 to which power here? They give me 64.
3.
What is the number? 3. 4 to the 3, they give me 64. This is 3 here. This is true. Because 4 times 4 is 16, times 4 is 63. 64, sorry. So 3. So the star here is 3. Now for the second one, logarithm 9 over 27 to the base 3. By using the properties is equal logarithm of the first one minus the logarithm for the second one. So they give me a log of 9 to the base 3 minus log of 27 to the base 3. What is the logarithm 9 to the base 3? What number if I multiply like 3 to the which power they give me 9? 3 to which power they give me 9?
2.
is 2. So the answer here is 2. This is equal to minus a 3 to which power they give me 27? A 3 to the which power they give me 27 is a 3, yes. Because 3 times 3 times 3 is 27. So 2 minus 3, and they give me 2 minus 3 is minus 1. So the answer is minus 1. For the last one, number 3. So 1 over 3 is equal 1 over 3 logarithm 125 to the base 5. What is logarithm 1 over 3 125 to the base 5? I ask myself here, 5 to which power they give me 125? 3, that's true. So that here is 1 over 3 so this is equal 1 over 3 times 3, and they give me 1. Any question? So it's clear how to use the properties. Okay. Example 2. Expand the logarithm. So I have 1 logarithm of 6x equal number 2 log of 5 to x to the power 3 y to the power 6 equal. What is that equal by using the properties of logarithm? Here we have, this is my a, this is my b. This is my a, this is my b.
It's log 2 of 6 plus log 2 of x.
Yes. To which base?
Base 2.
Base 2. Exactly. So again, this is my a here, this is my b, the same base 2. For the second one, who did the second one? Again, this is my a, this is my b, but we have to use different. We'll do the second one by using the property here. And I'm going to use this property too. Number 3 and number 1.
So what, it'd be 3 log base 5 of x
3
plus 3 times log base 5 of x.
Let me do it.
Sorry, yeah.
Yes. Go ahead.
Plus log base 5 of y.
Okay, then what I have to do,
base 5. And
then by using the property number 3. The 3 here, like where he said, come down. This goes down. And the 6 goes down. Log x to the base 5 plus log here 6 log y to the base 5. Any question? Any question for the 1 and 2? Here I use the property number 3 and I use number 1, 2. The 3 says this power goes down and this power here goes down. See? C goes down here. Equal C times logarithm of A to the same base. Any question? Okay, another example. Combining log. Number 1, 3 log x plus 1/2 log x plus 1. What is that equal? How can I combine the logarithm? I make it one logarithm. Combining mean make all the logarithm one logarithm. Expand makes more than logarithm. One logarithm make it like 2 or 3 logarithm. How can I combine this? So combining means going from this way to this way. First of all, the base here is 10. Why? This is the common logarithm. Like I said last time, we don't have to write the base. If the base is not written, this is mean to the base 10. If it's the base does not written, this is mean the base to the 10. This is called common logarithm from last time. So combining logarithm, first of all, this one here, the power goes up, and the power here goes up. So they give me here logarithm x to the 3 plus logarithm x plus 1 to the 1/2. Now, the base is the same. Logarithm with the same base, and we have plus here. So by using the first properties, this one plus this one, this make me log first one times A times B. So this is equal log this part times this part, x to the 3 times x plus 1 to 1/2. This is again called the common logarithm. Any question? Any question? Second example is exercise. So the example is combine the logarithm 1 over 2 log 2 to the power 6 minus 2 log 7 to the base 2. Now, I'm not going to make it exercise. I'm going to do it. This is the over sign question. So again, the 1/2 supposed to go up. The 2 goes up. Now this is equal log 6 to the base 2, everything to the power 1/2 minus log 7 to the power 2 to the base 2 here. Now we have subtract same base. This is mean we have to divide. So this is mean log of 6 to the power 1/2. This is mean square root of 6 over 7 square 49 to the base 2. Any question? Any question? Is it clear? Just you have to apply the laws for the logarithm. It's not hard. Just you have to memorize the laws of the logarithm. Now, second things in this section is called changing of the base. Change of base. You have to know if I have, for example, logarithm x to the base b, I can change the base here by making log x to the base I want, for example, a, over log b to the base a. So I change the base from b to a. This is a, this is a, and this is b. So I'll give you example, the simple example for these things. You have to know, like for example, how to change the base. Change the base for log 7 to the base 3. So if I want to change the base here, instead of 3 to the exponent to the e number, the number e, so I can set the log of 7 to the base 3 is the same as log 7 to the base e over log 3 to the base e. What does that equal? Log 7 to the base e, what does that equal? Log 7 to the base e, what does that equal? No, I don't need the answer. I need, what is that? What is the name for this logarithm? We talked about this last time.
Natural log of 7.
Natural logarithm, exactly. So this is ln, natural logarithm of 7. And log of E is ln of 3. Natural logarithm. Thank you, Angel. Thank you. Who answered the question? Will?
William.
William, yes. So, yeah, logarithm for the base E is the ln function from last time. It's called natural logarithm. This is just how you can change the base. Any question? Or you can change the base, not E, whatever, like 5, 7, 10. But the best thing is to use the base E. Okay, now let's go to the 4.5. Exponential and logarithm, logarithmic equations. So we're going to learn how to solve any exponential and logarithmic equations in this section. We have some steps. I'm going to show the steps for the exponential function and for the logarithm function. So here, I'll start talking about the exponential function. Exponential equations. This is my first step. Then I'm going to go over the logarithm exponential equations. So for the exponential equation, there are some steps to solve the equation. I'm going to explain the steps by the example. So for solving any exponential equations, first things we have to isolate the exponential expression on one side of the equation. We have to move all the exponential to one side and all the numbers on the other side. Then you have to take the logarithm for each side, and using the laws of logarithm by the previous section. Then in the end, we have to solve the variables. So let me give you an example now how we can use these steps. Solve 3 to the power x plus 2 equals 7. So I'm going to use this step by step. Isolate the exponential expression on one side. So here I have the exponential expression in one side and the other side is the number. So the first step is done. 3x plus 2 equals 7. Second step, take the logarithm for each side. So next step is log 3 to the x plus 2 equal log the 7. I prefer to take the common logarithm to the base 10. This is 10, base 10. Now by using the properties here, number 3 for the law of the properties, Logarithm for a to the base c to the power c, c goes down, and they give me c logarithm a to the base a. So this is my power here. This will go down. This goes here. So now I get x plus 2 logarithm 3 equal logarithm 7. Now I'm trying to solve the equation. This is like equation. I need to find x. So to do that, first things I have to divide both sides by logarithm of over 3. So I have to divide here by log 3. Log 3. So when I divide both sides by log 3, this cancelled here. The side cancel each other. Now I get x plus 2 equal log 7 over log 3. Again, log 7 over log 3 is not the same as log 7 over 3. This is wrong. Why? By using here. Log a over log b is not the same a divided by b. See this one? This is not equal. So this is not equal log 7 over 3. This is completely wrong. Now I have to subtract 2 from both sides to find the value for x. So I minus 2 minus 2. What I get? X equal log of 7 over log of 3 minus 2. This is my value for x. Any question? Any questions? Is it clear how to use the steps here?
Yeah.
Okay. So now let me give you another example. Example 2. E to the power 3 minus 2x equal 4. Or no, not equal 4. I make it like here minus 4 equal 0. So the first step here, isolate the exponential exponent in one expression on one side. So I need these things. This is expression equation. This expression I mean, this is exponential expression. I need it on one side. And everything to the other side. So I have to move this one to this side. I have to add 4 for both sides. Now I get e to the 3 minus 2x equal 4. Second step, I have to take the logarithm. But here, I prefer to take the natural logarithm. Why? Because when I take the natural logarithm, I can cancel the e. Because ln of e equal 1. This is from previous section. Ln of e equal 1. So take now the natural logarithm for both sides. Get ln of e 3 minus 2x equal ln of 4. Now this power is supposed to goes down by using the properties from last time. This here. This power goes here. So I get 3 minus 2x ln e equal ln 4. Ln e is 1. So this is like I multiply everything by 1. So I get 3 minus 2x equal ln 4. I need to find the value for x. So I have to subtract 3 from both sides. Or I move this one. Try to move this one to this side. And I move this one, the ln, to this side. So to move the minus 2x to this side, I have to add 2x for both sides. And to move the ln 4 from this side to this side, I have to subtract ln 4 for both sides. So I get 3 minus ln of 4 equal 2x. Now I have to divide all the side by 2, or I have to multiply by the reciprocal of x. So I multiply by 1 over 2, multiply by 1 over 2. So now I get 3 over 2 because I have to distribute everything here. 3 over 2 minus ln 4 over 2 equal x. And this is my answer. I get question. The question is, can you subtract 3 on both sides and then divide by minus 2? Subtract 3. Yes, you can. Yes, you can. The same things, Martin. If I subtract 3 from both sides, then I divide by minus 2, the same things exactly. So you can also, why did I use ln? Okay, because when I see the natural here, the number e is the best things to use the ln, the natural logarithm. Why? Because ln of e is always 1. This is very nice. If I want to use logarithm, it will be good, but it's not like ln of e, because I know ln of e is always give me 1. So I can cancel here ln of e. I mean, for canceling, like I multiply by 1. Okay? Yes, for e is better to use the ln. For e, always use the ln. It's easy to use the ln. For anything else, you can use the common logarithm, log to the base 10. But for E, I prefer to use the len. Why? Because len of E is always 1. Okay? Here again, you can subtract 3 from both sides and divide it by -2. It's fine. But also you can like moving this one to this side and moving this one to this side by adding 2x from both sides and then subtract len 4 for both sides. The same things. The answer is the same. 3/2 minus len 4/2. Any question? Anyone has a question? Is it clear? Okay. Let's give another example. I mean, like, let's go to the logarithmic equations. So now, like I started this section, I said exponential equations. Now we're going to the logarithmic equations. Okay. So now the logarithmic equations. So the logarithmic equation, we have like steps. The steps like exactly the exponential equations, exponent equations. So the steps like this. The same step exactly, but we have different change. First things, we have to isolate the logarithmic term on one side, write the equation in exponential form, solving for the variable. Example. Solve len x, no, 4 plus 3 logarithm 2x equals 16. First step, isolate the logarithm term on one side. What I have to do? How can I isolate it to one side? What I have to do? I need the logarithm on one side and everything on the other side. What do I have to do? First step,
You subtract 4.
Yes, subtract 4 from both sides. When I subtract the 4, I cancel the 4 from both sides. I mean from this side. Now I get 3 logarithm, 3 log 2x. 16 minus 4 is 12. Now what I have to do? What's the next step? I need just only logarithm on this side. What I should to do?
Divide by 3.
Divided by 3. Divide by 3. Divide by 3. Or like Chem, he said, I can write it in the exponential. Yes, I can put the 3 up, but it will be like so complicated. I prefer to remove the 3 by canceling the 3, dividing both sides by 3. So I can put the 3 up and I get like exponential. That's true, but would be like more complicated to solve the equation. I prefer to remove it by dividing both sides by 3. So when I divide the 3, I get now logarithm 2x equal 12 divided by 3 is 4. This is the first step. Second step, write the equation in exponential form. How can I write these things as exponential form? So I know this is to the base 10 here. This is mean 10 to the 4 is equal to x. So to write the equation in exponential form, this means I have to remove the logarithm and I have to write it in the exponential form. This means 10 to the 4 is equal to x. Third step, solve for the variable. What I have to do now? How can I solve x only? I get x.
Divide by 2.
Divided by 2. So I divide by 2. I get now x equal, so 3 x equal 10 to the 4 over 2. What is that equal? This is like 10,000 over 2.
IK.
5k. 5,000. Yes. So the answer x is 5,000. Any question? Is it clear?
Yeah.
Okay. Another one. So, example. Find the logarithm for 25 minus x equal 3 to the base 2. So I using step by step, isolate the logarithm term on one side. The logarithm here is already in one side and everything to the other side. So the first step is done. Write the equation in exponential form. How can I write this one in exponential form?
Two to the power 3 equals 25 minus x.
Perfect. 2 to the power 3, this is equal 25 minus x. True, Jim. knowing this is true. Now what I have to do? Now I have to solve it. The third step, solve for the variable. I need to find the variable x. Two to the 3 is 8, equal 25 minus x. What is the value for x? What is the value for x? $17, exactly. This is true. So how he think? Because I have to subtract, or like I said before, move this one to this side and move the other one, this one, to this side. I do 2 steps in one time. Why I do this one? Because we finished chapter 1, we finished chapter 2, now we have to do it fast. We don't have to do it step by step. So to move this one, we have to add x for both sides. So I get x. Now to move this one, we have to subtract 8 from both sides. So I get 25 minus 8. So x is equal to 25 minus 8 is 17. This is my answer. So the value here, x, is 17. Example, another example. The last example in this section. Solve log of x plus 2 plus log of x minus 1 equal 1. First of all, this is log without the base. This is mean the common logarithm. The base here again is 10. The base here is 10, but we don't have to write it. So we're going to do it step by step. First one, he said, isolate the logarithm term on one side. So it shows here everything to the one side. But we have to use the law of logarithm. The law of logarithm is here. Log A plus log B to the same base is the same as log A times B to the same base. Log x plus 2. So we have here my plus, and we have the same base. So we have to combine these two logarithms to one logarithm. What is the one logarithm? It's multiplying this by this, because this is my A and this is my B. So x plus 2 times x minus 1 equal 1. So I get one logarithm. Now, using the steps for solving, write the equation in the exponential form. How can I write this in exponential form? How can I write this one in exponential form? Ten to the 1 is the same as inside. So x plus 2 times x minus 1 is equal here 10. 10 to the 1. This is the exponential form. Now multiply this parentheses with this parentheses. Get x squared plus 2x minus 2x minus x minus 2 equal 10, because 10 to the 1 is 10. Now simplify these things. I get x squared plus 2x minus x is x, minus 2 minus 10 is minus 12, because I want to subtract this one, go this one to the side. So minus 12 equals 0. So now I get quadratic equation. I have to solve this quadratic equation. What is the solution for this quadratic equation?
4 and negative 3.
4 x plus 4 and x minus 3. This is what you said?
Yes.
Okay. Minus 4 times minus 3 is negative 12. 4 minus 3 is 1. This is true. Thank you. Now we have to solve it. So to solve this one is x plus 4 equals 0, or this thing's x minus 3 equals 0. So now here to solve it, subtract 4 from both sides, x equal minus 4, or x add 3 for both sides equal 3. Now to check this solution is work, you have to plug inside the formula here. Logarithm minus 4 plus 2, I get logarithm of minus 2. And this is wrong, because there is no logarithm for negative. So the 4 here is not working. This is not a solution. The only solution is x equal 3. Why here is not working? Because when you plug the negative 4 inside the logarithm, they give me a negative form. So here, not working. Why? Because log 4 minus 4 plus 2 is negative 2, plus log negative 4 negative 1 is negative 5, equal 1, and there is no logarithm for negative numbers. The number here must be positive. So this is wrong. That's why x equal minus 4 is not a solution. Any question? So this is not a solution here. Why? Because I can sit here, there is no log for negative. So the answer here is only x equal 3. Any question for this one? Anyone has a question? Is it clear? No questions? So now we learn how to solve any exponential equation by using the steps 1, 2, 3, and to solve any logarithm equation by the steps 1, 2, 3. So the section is finished. Do you have any question from this section? How to solve any equation? Okay. So now let's go to the 4.6, the last section in this book, in this chapter. 4.6 is the exponential growth. This is like easy section and simple in the same time. There is just one formula, and this formula we're gonna use it to solve any question. Okay. So the exponential growth is increasing by the model we have a model here. This model can work for any exponential growth. It's n of t, n of t equal n0 e to the power r times t. So what is n of t? What is n0? What is e to the r rt? So where here n of t, this one, is the population at time t. And n0 or n0, this is called the initial size of the population. And t, this t, is called the time. And r, this one, is called the rate of growth. Any question for this model? So you have to know this formula, and you have to know what does this mean n of t, n0, r, t. Does the r have to look like that? What do you mean look like that? Does the r have to look like that? What do you mean? knowing. Yes, it's supposed to be like a small r, like this. The letter R, yes. Yes, like this, R. Like this. Small r. So let me give you an example. What is to explain what is, how can I use this model or this equation for a growing growing of population. Okay. This is my example. Who will read this example for me? Who will read the example?
May I?
Yes.
The initial bacterium count in culture is 500. The biologist later makes a sample count of bacteria in the culture and find that the relative rate of growth is 40% per hour.
Okay. First step. Thank you. So look, the bacteria, I have a bacteria. This bacteria is starting by 500 bacteria. So I have like, for example, this dishes, and this dishes has like 500 of bacteria. This is the beginning. At T0, at the beginning, the initial, the number of bacteria is 500. 500. Okay? 500, this is mean like N0, when the initial size start. So the initial size here, it's 500. The dish has 500 bacteria at the beginning. A biologist later makes a sample count of bacteria in the culture and find that the relative rate. So here they give me the relative rate. The relative rate of growth is 40%. So R is given, the rate of growth. This is R. So R is given as 40%. And also is given the 500 is N0 at the beginning. The population size is the initial size. So it's 500. So now the question is, find a function that models the number of bacteria after T hours. So let me write down here the given. So the given N0 is given is 500. And also given the rate of growth. So this is given, and also the rate of growth is given. It's R equal 40%. 40% is supposed to be like as a numbers, 40 over 100. And 40 over 100 is the same as 0.4. This is R. Find the function. Now by using here the definition for the function, n of t equal n0 times e to the r times t. So n of t equal n0 e times to the power r t. R is given and n0 is given, so I can find the function. So n of t equal 500 e, r is 0.4 times t, And this is my function for this model. This is my function for this model. Make sense? Is it clear how can I think for these things? So first of all, you have to write down the given, then you have to apply the model function. Any question for the first part? Is it clear? Second part, what is the estimated count after 10 hours? Who will do the second one? The question asks me after 10 hours. What is the number of the bacteria in the dish? So who will do the second one? What's the estimated count after 10 hours? By using this function. So for B, they give me n of t equal 500 e 0.4 times r times t, sorry. The question at 10, after 10 hours, at t equal 10, what is, the question is, what is n of t? So to find n of t at 10, you have to plug the 10 inside this function. So n of 10 equal 500 e 0.4 times 10. And this gives me 500 e times e to the power 4. And because we don't have to use the calculator, so the n of t, n of 10 is equal 500 e to the 4. This is my answer. Any question? Anyone has a question? So number B is done. Number C, after how many hours will the bacteria count reach 80,000? So for C, they ask for the time when n of t equal 80,000. For the number C, after how many hours? So they ask for time for t. Will be count out like when the n of t is 80,000. So
we said 80,000 equals to 500 times e to the 4.
exactly. So n of t, so n of t is given here. I put it like 80,000. 80, 1, 2, 3 equal 500 e 0.4 times t. The question is asking about the t. So this is like exactly the previous section to solve exponential function. So it's 80. 1, 2, 3, 4. 80. Okay. Let me give space here, or I'll put comma. So this is 80. So now divide both sides. I have to solve it. This is like exponential equation. To solve the exponential equation, I have steps. Isolated the exponential equation on one side, take the logarithm, solve. So I have to make the exponential on one side, then take the logarithm. So I have to divide the 500 from both sides. So divide by 500, divide by 500. So what I get now? E to the 0.4 t equal 80,000 divided by 500 is 160, I think. 160. Now take the ln for both sides. So ln e to the 0.4 times t is equal 160. Ln 160. So ln of e is to the power 0.4 t equal ln 160. Let me do it here. So ln e 0.4 times t equal ln of 160. Like I said last time, when you see e is the better to use the ln for both sides. So now I get 0.4 t, because ln of e is 1, ln 160. The question is asking about t, this t. So t, divide both sides by 0.4, get ln 160 over 0.4. And this is my answer. Any question? Any question? Okay, the last one is sketch a graph of the function n of t. So the last one is D, sketch. I have to graph the Cartesian plane. So this sketch by using the 4.1, by using section 4.1, first section. This is exponential function. And the exponential function, like I said before, to graph nt. So I know n of t equals 500 e 0.4 t. So this is exponential function multiplied by 500. So at 0, this is my t, this is the time, and this is n of t. At time 0, they give me 500. So at 0 is 500 here. And this is exponential function, and I know the exponential function look like this from first section. When I said the a is positive, A is 500 is greater than 1. So the graph will be something like that. Because it's greater than 1. Why? Because 500 is greater than 1. So the function at 500 here, and the graph will be something like that. But in our life, we don't have negative time. This is -1, -2, -3. Here is 1, 2, 3, 4. We don't have negative times. We don't say the time is now -10 or -5, or we don't say, for example, -5 seconds or -7 seconds. So this is mean we have to remove this side of the graph. So the graph only has domain from 0 to infinity. Be something like that. Okay? It makes sense why I remove this side from the graph? Because we don't have negative time. Any question? Any other question or anything? Any question for this example? It makes sense? Clear? Okay, if no questions, let me give you another example. This is the last example for today. Who will read this question? Who will read it?
I will.
Yes, yes.
The count in the culture of bacteria was 200 after 2 hours and 12,800 after 6 hours.
Okay, thank you. So the bacteria after 2 hours, the number of the population is 200. By the way, this is a over-assigned question. And after 6 hours, the bacteria becomes 12,800. So I know the equation is n of t is equal n0 e r times t. So 200 after 2 hours, like at time equal 2, the n of t is equal to 200. At time equal 6, the n of t is 12,800. So now I can, the first question, what is the relative rate of growth of the bacteria by percent? So the question for the first part, what is R. They ask about R. Slope. Angel, this is not linear function. If it's linear, this is 100% true. But this is not linear function. The growth is look like this, something like that. But the linear function is something like that, line. But this is not line. At every time is different. But here is the same, is smooth. So what's R? To find R, you have to write two equations. First equation is at 200 at time 2. This is mean instead of n of t, I can write down 200 equal n0 e. Instead of t, I have to put 2 r. And for second one is 12,800 is equal n0 e 6 times r. Now I get two equations. The first one this, the second one is this. Divide 2 by 1. So divide this by this. So divide 2 by 1. So to divide this by this, I get 12,800 over 200 equal n0e 6r over n0 e 2r. First things you have to know, the n0 with the n0r cancel each other. 1264, right? You sure 64? 20 with 20. Okay, that's true. Thank you, Angel. So 64 equal e to the 6r divided by e to the 2r, and this is equal e here 6r, make it the same things, r2, 6r, 2r, 6r, okay, 6r, because we have the same base, this means 6r minus 2r from first chapter, and this is equal e to the 4r. So now I get 64 equal e to the 4r. Take the length for both sides. Take the length for both sides. I get length 64 equal length e to the 4r. Now I get do it here. Steps. So this is like exponential equation from the previous section. So 4r equal length 64. Divide by 4 for both sides. R equal length 64 over 4.